Well, this module is on naming ionic compounds. So we want you to be looking at the symbols in the formula really carefully.
And the first step is asking, is there a cation and anion, which you can think of most commonly a metal and a nonmetal? If yes, we need to proceed with the ionic compound naming process. If no, and there are only nonmetals present, then we want to use the process for naming covalent compounds.
And that's coming up soon, separate module. So go ahead and take a minute and print the periodic table out, and you're going to use this. It's going to help you to personalize that periodic table to be yours.
Wait, didn't we just say that? Is that supposed to be?
Yes, I believe in redundancy, John. I believe in redundancy, John.
Good reminder.
I believe in redundancy, John.
Okay.
Okay.
So looking at the periodic table, we have it coded sort of by the three classes. So we have this bluish region, this metals, which are majority of your periodic table you can see. We have this yellowish region we call the nonmetals, including the lone hydrogen sitting up over to the left. And then lastly, we have the metalloids, which are these middle blue ones right along that bold dark line, or a number of them.
And the thing to keep in mind is all of these that look like they might be nonmetals are actually metals. So even though polonium is in group 6A, it looks like it might be a metal, a nonmetal. It's a metal because it's underneath the metalloids. Also, keep in mind that the intertransition metals, the lactonides and actinide series, they are also metals.
Mm-hmm.
So we're going to talk about these here a little bit more.
And the other thing with the metalloids is sometimes you'll see books that list polonium as a metalloid, and sometimes, acetine or not. So
they're not sure, but those are both highly radioactive, and I hope nobody ever has to actually play with those.
Yes. All right, so let's review some of those ions that are formed. So if you look at group 1A, you can think of those always forming a +1 charge.
Group 1, 1. Okay.
Group 2.
+2.
+2.
Okay.
From group 3, aluminum always forms +3 charge.
Is that only aluminum in group 3?
Well, gallium and indium usually do too, but
a good rule is just aluminum.
Just aluminum, yeah. So remember that your metals are losing electrons to move and become like your prior noble gas.
That's why they have the positive charge.
So now if we look at group 5A, so nitrogen through arsenic form a -3. Group 6A, oxygen through beryllium form -2. Group 7A,
-1.
-1.
Yeah.
So you'll see your nonmetals are gaining electrons to move to become like the next noble gas, which, if you remember, do not form any because they already have a full octet.
Okay, cool. Is that all we need to know?
No, there's a couple of these other areas. So here you got your ions that vary in charges.
So all of the metals that are in this transition metal area here and this inner transition area here, they all have variable charges to their ions when they form.
Right, except for 3 little exceptions which we'll point out, which are silver, cadmium, and zinc. And these 3 are always fixed. Your zinc is a +2, your cadmium is always a +2, and your silver is always a +1.
I write it right on my periodic table, so I have it with me whenever I'm taking my quizzes. Hint, hint. Okay, John, is there anything we should know about the metals that are underneath the nonmetals?
Yeah, those group 4, tin and lead, are 2 that actually can vary. So sometimes they're +2, sometimes they're +4.
And probably the same thing is true with bismuth as well. Well. Okay.
So if we look at the different kinds of cations here, the type 1 cations basically are those elements that form an ion with a fixed charge. So with only one possible charge, this includes all your main group metals of group 1, group 2, and then that one aluminum element in group 3.
So those are the only metals that we can say have a fixed charge with reliability.
Correct.
Okay.
Your main groups. And then we get those 3 transition metals that are fixed that we highlighted.
Oh, those exceptions. I keep forgetting about them.
There's always some exceptions to the rule.
Write them down. Write them down.
Then the other kind is the type 2 cations, which are basically form differently charged ions. And this is most of those transition metals along with those couple of main group metals that we saw with your lead and your tin.
Boy, tin is SN and lead is PB. They're not American names.
No.
Okay.
And then you have your iron can form Fe2 plus or Fe3 plus as a type 2 cation.
As in many of the other transition metals, they can
Exactly.
form several different types of ions when they form ions. When they lose electrons, because they're metals, to form an ion, they might have a +1, a +2, a +3, blah, blah, blah.
Yeah, sometimes you'll even see +6 or +5.
Wow. Okay, cool.
So let's look at this slide for a minute.
Remember Thinker Buddy? When you see Thinker Buddy, you need to stop and kind of think about it. And if you're working with a friend, it's even better. Try to come up with a basic set of rules. You know, study the names. Study the name and the formula. Can you come up with a set of rules? And wait a minute. Pause. Okay.
Okay.
Hopefully you've thought about this for a minute or two. This will help you to really engage and to really follow what's coming next. Okay.
Okay, so let's look at the basic steps. So the first step is basically naming the metal ion or the cation.
So barium is the metal ion, okay?
The second step is naming the non-metal ion or the anion.
Without the word ion.
Right.
Right, just like all non-metal ions are IDE, okay?
Exactly.
Okay, got it. That makes sense.
Okay, so the next one we can take a look at is naming some with the polyatomic ions.
Oh, those polyatomic ions, we need to make sure you have them written down in your notebook, on a note card, wherever. Don't try to memorize them. They're so subtly different from each other sometimes.
So if we look at these, we can see that these fall similar in terms of naming the metal or your cation.
Name the metal barium, and then we
can name our polyatomic. So if we look
NO3 nitrate.
Correct.
Okay.
All right, and then the other kind to look at is naming those type 2 metals, so the variable
Those are the
charge.
metals with the variable charge. Okay. So let's study this for a while. Make sure you hit pause. Okay.
Okay, so let's look at some of the rules. So again, naming the metal. You can see there's common here. Then indicating the charge on the metal with these Roman numerals that are in parentheses.
John, I think nobody is going to come up with that, and we just want you to know that, well, maybe some of you will come up with that the charge, the Roman numeral indicates a charge on the ion. We don't expect right answers here. We just want you to sort of thinking about making the relationship. What the heck does this Roman numeral mean? Well, it means that it's a charge on that metal in each case.
And we'll definitely get to some examples and show how
we're going
to
to give you, okay.
So then if the anion is your monoatomic, you're basically adding the ide.
Like sulfide, chloride, okay.
And if you're dealing with the anion of polyatomic, you're naming the ion.
Okay, carbonate, done. So I think it's a good idea to give them a list of rules spelled out. I'm sure they kind of got the idea of it now, but let's get them spelled out.
So first off is naming that cation, again dropping the word ion. So if you're looking at a type 1 cation, like your group 1 and group 2, say for example magnesium, versus if you're naming a type 2 cation, most transition metals have your various charge. So your iron 2, like we said, the 2 plus represented by the Roman numeral 2, the 3 plus represented by the Roman numeral 3. Again, think of those exceptions. Those zinc, silver, and cadmium are type 1 cations, and then lead and tin are type 2 cations.
Oh, the only polyatomic ion on my list is the ammonium ion. So when we put that in a name, we just say ammonium and then we cross out that ion. Ah, okay.
Yeah, a polyatomic
That's the only
cation.
positive one, yep.
Yep. And then for naming the anion, like we remember just adding the IDE ending for those monatomic, or naming the polyatomic ion. Again, dropping that word ion at the end.
Okay, so we'd really be using a lot of the polyatomic ions.
All right, so now let's take a look at some examples here and name some or determine the formula of some.
Remember, Thinker Buddy says pause. So if you really want to get the most out of this class, challenge yourself. Pause and then move forward once, so you can have more questions that way. Okay, so shall we work this one out?
Yeah.
Okay, so copper 1 means copper has a 1 plus charge. And I'm going to put my finger on bromide in the, of course, you do need to know now the symbols and the names.
Yeah.
I'm going to put my finger on my periodic table, and I learned that bromine is Br, and it's in group 7, so it has a 1 minus charge. And following the rules for writing formulas, I'm going to write CuBr.
Yep.
Okay. Same thing with sodium chloride. Na is in group 1, and it's +1. It's hard for me to remember sometimes that Na is sodium. It should be an S, but it's not. Na is sodium. I just wanted to point out that I tend to write +1 instead of 1 plus, because in the olden days when I took chemistry, we always wrote +1, but in the modern days, they're starting to write 1 plus. Don't ask me why.
Yeah.
Okay, so Cl is, I'm going to do it -1. It's hard for me to change. So when we put them together,
get sodium chloride.
Okay.
So this one here with the aluminum, so you can think of Al is in group 3. It's a 3 plus or +3.
Yep, that's me again.
Bromine is in the group 7A and it forms a -1, so bromide ion. So when we name that,
So we don't say aluminum ion, bromide ion for the name of the compound.
No, we can just list aluminum bromide.
Okay.
Where's
cesium? Where's cesium?
Gotta search our periodic table for that one. Oh, there it is, hiding down in group 1.
So that means it has a 1. I'm going to do it 1 plus. Okay. And nitrite. I don't know what nitrite is.
Oh, that's your nitrogen.
Oh, right. And nitrogen is in group 3A.
Group 5A.
Oh, right. 5A. So we're going to work backwards. So it has a charge of 3 minus.
Yeah.
Okay. So we're going to write the formula.
So you can think of here's you can do your
loop
and swoop. So you can do that and think of there's going to be 1 nitrogen and 3 cesium to get basically CS3N.
So the next one is the naming.
Yep.
So we know it's got a Ca in it, and Ca is calcium. So I'm just going to write calcium. And then it has F, and F is fluorine, but it's an ionic compound now because a metal is present. So we have to drop the ene and write IDE.
Right.
Yay,
Good.
I like it when I do it right. Okay.
So now we'll look at some that have some polyatomic in there and do a similar kind of approach. So this first one, ammonium, well, we can think back, that's that 1 polyatomic that's positive. So NH4, the +1.
I'm going to put the whole thing in a parenthesis because that just makes me feel better. And Cl doesn't have a parenthesis because it's not a polyatomic. Oh, so it's just 1 to 1.
Yep. So we can just get NH4Cl.
So on a quiz, you won't see those parentheses. And if I didn't include the parentheses, if I did include the parentheses and wrote it like this, would I be wrong? Well, probably we wouldn't take points off on a naming lab, but if you were going to report a paper, you'd have to take those parentheses away when the subscript of 1 is next to that.
Right.
Okay.
All right, so this one's coming up with the name.
We have a K-school.
K-school.
Oh man, that's a funny looking polyatomic ion. So I know that I have a metal present, and that's potassium.
Right.
And then I'm going to put parentheses on the everything else. I've got a metal plus something else. I might have to look this one up, and you might see it in several different forms. This is called the acetate ion.
Right.
And it has a -1 charge. Potassium has a +1 charge. So we would name this as?
Well, potassium be the same, and then acetate is acetate.
And you may see acetate written like this, CH3CO2.
2. Right.
Okay, that's another one. A minus. You may also see it as C2H3O2 minus.
Right.
Those are all the same ways of writing acetate. Sorry it's confusing, it just is. Okay, the next one.
Okay, so here we have another one with a metal present. Mg we can think back as your +2
Okay.
magnesium. And then Cn in parentheses.
Has a -1.
And that one, if we look at our list, is cyanide.
But the charges don't matter when we're writing these because we know the fixed charge.
Correct.
So all we have to do is write the metal ion,
Magnesium.
and add it to the cyanide ion.
Exactly.
Just slap them together and drop the words ion. Okay.
All right, so now we need to come up with a formula for this guy. And this has one of those type 2 cations with your iron.
So iron is Fe.
Yep. You can think of with that Roman numeral 3, that's telling us the charge, so 3 plus. Ooh, phosphate. Now I really got to
P.
refer to my list. Wait, isn't
Double
P
check.
phosphide?
Oh, right. So we have to PO3. And now in parentheses might be very helpful.
Oh, wait, isn't that PO4?
PO4.
And then 3 minus.
3 minus.
There we go.
You know what happened? I didn't check my list,
Yeah.
and I went from my memory, and my memory isn't as good as it used to be. So I always tell students, unless you've got a photographic memory, be sure to refer to your polyatomic ion list every time. Okay, so 3 and 3, do we cross? And we do the loop and sloop? Then we have to simplify.
Simplify.
Because you'd only need one for each.
Right.
So what's the formula for that one?
Well, we just end up with one of each, so FePO4.
And is a metal present? Yes. The metal's name is rubidium. I have to look that one up. And NO2 is a polyatomic ion that looks an awful lot like that nitrate, but it's not the nitrate.
Yeah.
It's nitrite.
One less oxygen.
So the name for this one is?
Rubidium nitrite.
So if you have any questions on these, just be doing these in your notebook and be sure to post.
All right, so far you've learned how to write ionic formulas. We've now looked at naming ionic compounds and sort of going between the two of them.
They need to go back and forth. Once you get the name, you should write the formula. When you get the formula, you should write the name, cover over one, and work backwards to double check your work.
Exactly. So now let's look at those type 2 metals again, the ones with the variable charge, because you're not going to have to memorize which charge is which. You don't have to memorize iron 2 versus iron 3.
Oh, good, because that's really stressful.
Yeah. So there's a couple different ways we can figure it out. One will even be given the name with the Roman numeral, which tells us the charge, or we'll have the formula and we'll have to reverse loop and swoop to calculate that charge.
Kind of like we were just doing with the polyatomic ions. Okay.
Exactly.
Okay.
So let's take a look at some examples.
So we're going to do these by hand, so bear with us.
I'll make sure.
Okay. FeCl3. Okay. So is a metal present?
Yes, I see iron there. Definitely
Is it a metal with a fixed charge?
No, it's one of those type 2 cations.
That's our unknown. And what's the charge on chloride when it forms an ion? Because it's iron There's an iron here, and there's a Cl. Because it's an ionic compound, it's chloride. So the charge on chloride, each one is a 1 minus. So I could do the loop and swoop.
Yep. So if we come up here, what we can do is we can take, or if we do the reverse loop and swoop, we can take this, we can take your 3 from your Cl and reverse it up. And then you can think of down here next to iron essentially is a 1. And we don't have to write it, but we can take that and swoop it up. And when we do so, this will tell us our charges. So now with Fe, we can see with that 3, we know iron's a metal, so it has to be 3 plus. And chlorine here is a nonmetal, tells us 1 minus. And we can check and verify, does our periodic table have a -1 for chloride? Because we always got to check that anion. Well, yes, that's true. It's in group 7. So if that comes out true for chloride, then we know that holds true for iron. And now if we write your name for this, you can think of this as where we'd write out iron 3 chloride.
One thing I might say, when you're working at home, you don't have to put the top on that. You can just put parentheses, capital, 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 end of parentheses, and that'll work just fine.
True.
So if you're typing it in. So when you want to prove this, we have Fe with a +3 or 3 plus charge, and our Cl with a minus or 1 minus charge, and there's 3 of them. I'm going to do my math and prove this. You won't have to do this most of the time, but if I have 3 chlorides with a -1 charge, that makes I have a net -3 on my molecule, and I have 1 iron here, and it has to be a +3, and they have to add up to equal 0.
Right.
So we've proven that it does work. So to compare and contrast, we're going to try doing Fe2O3. You want to do the loop and swoop?
Yeah. So similar, we can take our 3 here, and we can loop that back up. We can take our 2 here, swoop that back up, so reverse loop and swoop. And again, we write out, we basically get Fe, 3, and we know it's cation, so positive, and O gets the 2, it's anion, it's negative, and then we can check and make sure, and yes, oxygen always forms a -2, therefore iron has to be a +3 in this case. So if we name this out, here's another one with iron 3 oxide.
Okay, good.
All right, let's look at a couple more examples.
Okay, let's do copper with, let's do Cu. I almost gave away the name. And you know, when you're fluent in it, as we are, we don't necessarily see just the formulas. We see it all kind of at once. It's like my second language. So we're going to give you this. So is a metal present?
Yes.
And is it a metal with a fixed charge?
No.
So we have to figure out what the charge on that ion is. We're going to work backwards. We're going to look at nitrate on our periodic table and on our list of polyatomic ions, and it has a -1 charge. And since we have 2 of them, it's going to be a net -2. So I know I have to have a net +2. So it's understood from the formula that that's a 1.
Mm-hmm.
Okay, we don't write that in. That's why I circled it. So I have to have, if I only have 1 copper, then it has to be a +2 charge. Another way you could do this, and this is John's way, which is absolutely awesome, is that reverse loop and swoop. You have to remember that that 1 is not really there, but it's understood. And so what do we do, John? We take that 1 and...
Yep.
Oh, I'm doing it backwards. That's a swoop.
That's okay. That's a swoop. Yeah. Then you
And there's a loop.
Yep.
Okay, so either way, we know that copper is going to be a +2. So we would have to use the word for copper and then the parentheses with a charge that we figured out.
Right.
For copper, and we have to copy down the name of our polyatomic ion correctly. Copper 2 nitrate.
Right.
Okay. CuI to compare and contrast.
Okay. So if we take a look at this one, and we have Cu and I, so we can think of, well, there's one of each of these that we have implied here. And if we think of doing a reverse loop and swoop, so we can take your one here, reverse it up, take your one here, swoop it up here, and if we do so, that would give us copper as a +1, and that would give us iodine, or iodide, as a -1. And we can check, and yes, iodide forms a -1. So therefore, in this case, copper is forming a +1. So if we write out the name, in this case, the copper with parentheses would only have a 1 for Roman numeral, and then your normal iodide.
Okay, let's do a few more, maybe 2 more. Let's do MnO2. Okay, so do you want to try the loop and swoop?
Yeah, let's try that. Okay, so if we take our 2, we can reverse loop it up. Think if there's a 1 down here, we can reverse swoop it up. So in Mn, we can think of, well, based on this, we get +2, and based on this, our oxygen comes out to -1.
Uh-oh.
Wait, can oxygen be a -1?
Nope. Oxygen's always -2, unless it's a peroxide, but this is not a peroxide.
Correct. So what does that mean? Well, this would be a case where we need to use our proof method. So if we want to figure out what oxygen actually is based on the periodic table, we can think of it's not ever going to be a -1.
So we'll go through, this is the one time you're going to have to do this, when you're not at, when it doesn't work to do the loop and swoop. When you figure out that O is not a -1, you go back and say, okay, is a metal present? Yes. And is it a metal with a fixed charge? No. So we have to figure it out. So oxygen is always going to be a -2.
Right.
And there's understood to be a 1 there. So 2 times 2 is -4. So our 1 manganese ion has to have a charge of +4, so that adds up to 0. So it would be a +4. So we would write that. Remember, it's not magnesium, it's manganese. And the parentheses would be the 4, and then you're going to write oxide for manganese oxide. And there's a pretty unusual charge. We don't see +4s too much. So, okay. And to compare and contrast, if we had MnCl2, then we can just do the reverse loop and swoop.
So this one we can do, and so we can take your 2, reverse loop it up. Think of the 1 that's down here, reverse swoop it up. So here that would tell us that Mn would be a 2+, and Cl would be a 1-. So you can see in this case, when we write it out, you're dealing with manganese again. in this case, we're only dealing with the 2, and then we got your normal chloride. And we know that this is valid because the Cl is truly a -1 based on your periodic table. Therefore, the manganese in this case can be the +2 for this formula to work.
Okay. So here's some quiz questions that you may see somewhere else. Hint, hint. So go ahead and name this. Once you get the name, do this out in your, write it out in your notebook, and then make your choice. Sodium oxide. How about COI2? Cobalt 2 iodide. Hopefully you're taking the time to pause this. CuSO4. Copper 2 sulfate. Okay, just a couple quick quiz questions. And now we're going to do one more practice example for you. I think there's only one more. I can't remember.
Yeah.
So lead 2 sulfate. I can't remember. We're in the middle, right? Lead is Pb. I always want to write L. Pb. The 2 means it's got a +2 or a 2+ charge. Sulfate is SO4. And it has a -2 charge. If I do the loop and swoop, it's going to be Pb2SO42, loop and swoop. But then you have to simplify to the lowest common denominator to get PbSO4. Again, the parentheses are left off. You don't need those parentheses, okay?
So if we look at this one now, CO3, PO42, this would be a perfect example to do our reverse loop and swoop. So we can reverse up the 3, reverse up the 2. So that would tell us your cobalt is a +2, your phosphate's a -3, and we can verify that. And yes, on our polyatomic list, we see that's true. So we'd get your cobalt, the charge of 2, and then you got your phosphate for the polyatomic.
Oh, here's a funny example. We haven't done any of these yet. So these are 2 polyatomic ions. You just smash them together to write the name. But let's write the formula correctly. The only positive polyatomic ion is NH4, and we know that's got a +1. And carbonate, I'm going to just put it in parentheses, is CO3, and it has a charge of -2. So we're going to do that just loop and swoop and bring the 2 down and then bring the 1 down around the CO3, 2 and 1. I'm not looping and swooping very pretty, am I? But
yeah,
the point is done. So NH4CO3, NH42 CO3. Note that the 2 is on the outside of the parentheses. You have to have the parentheses here to indicate that you have 2 ammoniums and 1 carbonate.
Okay, so here's one we can also try the reverse loop and swoop on. So we can take our 3 and reverse it up to where Cr is to give a +3 for that chromium. You think of the chromium as followed by a 1, so it's essentially going to move that guy up there to behind.
I'm trying to loop and swoop neatly.
Nice.
Okay. So chromium, CHROMIU, chromium, and the charge we figured out was chromium 3.
Right.
And with nitrate. So we just write it out completely as chromium 3 nitrate. So when I see tin 2 permanganate, I know tin has a formula of SN, and it's then one of those, metals that are over there that looks like it's a non-metal, but in this case it has a +2 charge. Ooh, permanganate. That's the something else. That's a polyatomic ion you're not going to see too often, but the polyatomic ion is MnO4. That's the whole polyatomic ion. It looks like metal, but it's not, and it's got a -1 charge. When we do the loop and swoop with that, what do we come up with?
Well, let's see. So if we take your loop and swoop, you can take your 2, you can loop it down here, take your 1, swoop it down here. outside O, yeah. So that 2
Make
should
sure
go
that's
over here.
Outside, yeah.
So the 2's outside, the
The
1's next to
parentheses.
this.
Good.
So then when writing it out, you can see you get SN MnO4 with the 2 on the outside of those parentheses.
So if you have any questions, be sure to ask. Practice this, run this through again, and whatever you've written the formula for, write the name for. Whatever you've written the name for, write the formula for, and then repeat it all again one more time and you'll own this stuff.
Just practice, practice.
Redundancy is everything, John.
That's right.
Redundancy is everything, John.
Okay.